Hello everyone, welcome back. Let's talk about another medium problem on Leetcode today. First, completely painted row or column, Leetcode 2661. In this problem, we are given 0 index integer array AIR and an m into n integer matrix MET. AIR and MET both contain all the integers in the range 1 to m into n. We go through each index I in the array starting from the index 0 and paint the cell in the matrix containing the integer array at I. And in the end, we return the smallest index I at which either a row or a column will be completely painted in the matrix. And in terms of constraints, it is given that all the integers of array and matrix are unique. Then in example 1, for the given array and matrix, at index 0 in array, we see 1. So we paint the corresponding cell in the matrix with blue color. Then at index 1 in array, we see value 3 and paint the corresponding cell in the matrix. Then at index 2, we see 4 and paint the cell containing 4 in the matrix. And now we see that this row and this column are completely painted. So we return I equal to 2 as our answer, because either a row or a column should be completely painted in the matrix. So we can return the answer either based on this row or this column. Similarly, in example 2, for the given array and matrix, at index 0 in array, we see 2. So we paint the cell containing 2 in matrix. Then at index 1, we see 8 and paint the corresponding cell in the matrix. Then at index 2, we see 7. So we paint the cell containing 7 in the matrix. Then at index 3, we see 4 and paint the cell containing 4 in the matrix. And now we see that this whole column is completely painted. So we will return index 3 as our answer. Now for the solution, in order to paint the matrix cell containing the element from the array, we need to search for the element in the entire matrix. This results in a time complexity of O of m into n for each search, where m is the number of rows and n is the number of columns. So to improve on this, the first thing we need to do is create a lookup table or a hash map to store the coordinates of each element in the matrix. This allows us to find any element in O of one time when searching in the matrix. So the key in the map will be the element and the value will be the coordinates. For example, for element 3, the key will be 3 and value will be 0, 0. For element 2, the key will be 2 and the value will be 0, 1 and so on. So this is how we will fill in the complete lookup table for the matrix. Next, as we iterate through the elements in the array, say with iterator I, we paint the corresponding cell in the matrix. If the cell's entire row or column is painted, we return the index I. For example, at index 0, we see the element 2. So we look up for 2 in the lookup table and paint the corresponding cell in the matrix. But how can we determine if entire row or the column of the cell is completely painted? A naive approach would be to mark the cell as visited and then iterate through all the n elements in the current cell's row to check if all the cells are visited or painted. Similarly, to check if the column is completely painted, we will have to go through m elements in the current cell's column. And if either of the check returns true, we would return our current index I. However, this approach is inefficient because for each cell we paint, we will have to go through n elements in the row and m elements in the column to find out whether the row or column is painted. So this will result in a time complexity of O of m plus n for each cell we paint. So if we notice, we have n elements in the given row and the constraints guarantee that all the elements in the array and matrix are unique. So if all the elements in the row are painted, we will get n painted rows. So how about we track the count of number of painted cells for each row? And now, instead of visiting each cell, we can simply increment the count of painted cells for the current row by 1 whenever we paint a cell. If all the elements in the row are painted, the count will reach up till n and we will return our answer. Similarly, we can increment the count of the painted cells for the current cells column whenever we paint a cell. And as soon as columns count becomes m, that means we have painted the complete column. So we can return the answer. Now let's see this in action. We can take array's row count and column count to keep track of the number of painted cells in each row and column. The number of rows and columns, that is m and n, for this example are equal to 3. So we start iterating through the array with iterator I, initially at index 0. Element in index 0 is equal to 2. So we look up for 2 in the lookup table and we get its row as 0 and column as 1. So we paint it and we will increment the count at the row 0 and column 1 by 1. Then at index 1 we see 8, which is located at row 2 and column 0. And when we paint this cell, we increment the painted cell count for row 2 and column 0 by 1. Then at index 2 we see element 7, which is at row 2 and column 1 in the matrix. So we increment the painted cell count for row 2 by 1, so it becomes 2, and column 1 by 1, so it becomes 2 as well. Then at index 3 we see element 4, which is at row 1 and column 1. So when we paint it, we increment the painted cell count for row 1 by 1 and column 1 by 1, so it becomes 3. And we notice that column count is now equal to m. So that means this whole column is completely painted, and hence we will return I equal to 3 as our answer. Now in terms of time complexity, it will be O of m into n, where m is number of rows and n is number of columns in the matrix. Because first we create the lookup table that takes O of m into n time because we go through each row and column in the matrix. And then again we will go through each element in the array to paint the cells in the matrix. That again takes O of m into n, resulting in overall time complexity of O of m into n. And in terms of space complexity, it will be O of m into n because we are using this lookup table which takes O of m into n space, and row count and column count arrays which take O of m and O of n space respectively. So now let's jump into the code part. First, let's create the lookup table. For that, we will need number of rows m and number of columns n of the matrix. I am creating a lookup table of size m into n plus 1 because values in the matrix are 1 indexed. That is, they start with number 1. The index in the lookup table will be the element and value will be the positions in the matrix. And the reason I am using lookup table instead of a hash map is because we are given that the elements in the array are in the range 1 to m into n. So using a lookup table is slightly cleaner and efficient compared to using a hash map. But using a hash map is also fine. Now we will iterate through each element in the matrix and fill in the coordinates of each element in the matrix at the index equal to element in the lookup table. Let's also initialize counters for rows and columns to track painted cells. Now we will iterate through each element in the array and paint the respective cells in the matrix. For the element at the ith index in the array, we will get the position of this element in the matrix from the lookup table and extract the row and column values for it and increment the number of painted cells for row and column in the respective counter arrays. And if at any point number of painted cells in the current row or column is equal to n or m respectively, then we have painted the current row or column. So in that case, we will return the index I. Otherwise, we will continue with the iteration. And in the end, if the loop doesn't return any index, then we will return -1. However, given the constraints of the problem, this should not happen, but this is just needed so that the compiler doesn't complain. So now let's submit this code. Awesome. So that's all for this video. I hope this video was useful to you. If it was, please give it a thumbs up and share it with others who might benefit from it. If you haven't subscribed the channel yet, make sure to hit the subscribe button and turn on the notification bell so that you never miss an update. Your support helps me create more content like this. If you have any questions or suggestions, feel free to leave them in the comments below. Thanks for watching and see you in the next one.